Okay, so today we'll solve GATE 2022 question. This is a question from functional analysis. This is question number 51. So what it is saying, let A bigger than 0 and dA is a linear operator is from L2 of R to L2 of R is defined by dA of f of x is 1 by root square root A f of x by A, almost everywhere, for f is in L2R. Then which of the following statements are correct? You have to check. The dA is linear isometry, dA is bijection, dA composed dA dB is d of A plus B, and dA is bounded from below. So these are the four options we have to check. Okay, so in order to solve this is the NPTEL reference. This you can check. Okay, so let's try to solve this one. So for A bigger than 0, dA is a linear operator from L2 of R to L2 of R. How it is defined? dA of f of x is 1 by square root A f of x by A. So first we have to check that dA is linear isometry or not. So let's check. So isometry means, so A, so this is option number A. So to check isometry, dA is linear isometry. Means dA f L2 norm is same as L2 norm of f or not. So let's check this one. dA f L2 norm. So this is by definition over R dA of f of x whole square dx to the power half. So just write down the definition, then you will get 1 by A over R f of x by A. So now let's make change of variable. So if we make change of variable, what will get? F of x A dx. So A and A will cancel out. You will get mod of fx dx to the power half. So this is the L2 norm of f. So what you've got? So you've got that L2 norm of dA of f is same as L2 norm of f. So which means, so therefore dA is linear isometry. So first option is correct. So therefore next what you have to check, that dA is bijection. So to check dA is bijection. So you have to check the dA is 1 1 and 1 2 or not. So note one, this is that. Note that isometry implies 1 1. right? Means, so you have to check that. So this is a standard fact for linear operator. As it is isometry, so therefore it is 1 1. So means 1 1 for you have to just check that kernel is the zero function. So so as it is isometry, so you have to check that operator kernel is 0, so and d of f is 0 means, so f should be the zero function, right? So in the kernel only zero functions is there. So as isometry implies 1 1, which implies, so therefore dA is 1 1. Now you have to check that dA is onto or not. 1 1 just easily follows. So for ontoness you have to check for any g, is there any function which will map under this map to g. So now to check dA is onto or not, so take g in L2 of R. Define this function h of x to be square root a g of ax. So now we will show that h is in L2 and under dA h will map to g. So first note that GA, why h is in L2. So you have to check the L2 norm of h. Over R. So if you calculate the L2 norm of, now make again change of variable as early. So if you make change of variable, here what we will get? So a cancel out, you will get basically gx square dx to the power half. So basically L2 norm of g, and we have assumed that g is in L2, so this is finite. So L2 norm of h is finite, which implies h is in L2 of R. So h is in L2 of R. Now calculate what is dA of h of x. So dA is by definition 1 by square root of a h of x by a, right? And what is h? H is this. So 1 by square root a into square root a g of a times x by a. So basically this is gx. So dA of h is mapped to hx, which implies dA is onto. So therefore what we got, that dA is both 1 1 and onto. So therefore, so dA is bijective. So therefore option 2 is also correct. Now I have to check that option number C, that dA composed dB is equals to dA of A plus B or not. So to check dA composed dB is d of A plus B for B positive or not, right? So let's check that dA composed dB of f of x. So what is this? If you calculate, so basically, so here view this as a function of some g. So dA of g of x, so this is then by definition, so this is 1 by square root a, that function dB f at the point x by a, right? So this is the by definition of dA. Now use the definition of dB. So this is 1 by square root a into 1 by square root b f of x by a by b means x by ab. So this is basically 1 by square root ab f of x by ab, so which is same as d of ab. So we get dA composed dB is d of ab of fx. So this is not as same as d of a plus b, so therefore this is not correct. So dA composed dB is not equals to d of a plus b. So here we got d of ab, not d of a plus b. So option number C is not correct. Now what is the last option? You have to check that dA is bounded from below. To check dA is bounded from below. So what does this mean, that bounded from below? Means we have to check that norm of dA of f should be bigger than some constant c. C times norm of f. So this is the meaning that dA is bounded from below. So note that as norm of dA of f is same as norm of f. So because this is isometry, so here c is basically you can take to be 1. So which is trivially saying that this is bounded from below, right? So dA is bounded from below. Means basically bounded from, because here dA of c is 1 here basically, and equality also there, so it is bounded from below. So option number D is also correct. So what we have got, that option number A, dA is linear isometry, it is correct. dA is bijection, this is also correct. Option number C is not correct. dA is bounded from below, it's also correct. So A, B and D are correct. Okay.